they have this board that has the red and the black, and it's split. And what it does is it shows what hit. Like maybe red, 5, and maybe this was, the next round it came up 7, and maybe it came up 6, 2, 4, and 24. And you look at that and you go, oh wow, look, red seems to be hot, and so are even numbers. So I'm going to bet on evens and red. And that's a misconception because, again, each time the roulette is played, that's an independent event. Okay, it's an independent event. It doesn't have anything to do with any of the previous rounds of roulette. But they put this up there to get you to not think logically that, probabilities are probabilities. And if it's an independent event, then there isn't anything that has to do with the previous events when we're talking about the next independent event. So again, if you're having kids, it's a 50-50 shot every time that a kid is born, whether it be a boy or a girl, because each birth is an independent event. So even if you're thinking about, like the family, the Dugars on TV that have 19 kids, if they had 18 boys in a row, and you ask what's the probability that the 19th child would be a boy or a girl, it doesn't matter about those 18 kids prior, the 18 boys prior, it's still a 50-50 shot whether it'll be a boy or a girl, because that's the probability, and it's an independent event. Now, if we were asking what's the probability of having 5 boys in a row, that is no longer an independent event, because you're asking for something, an independent event in a specific order, and that's different, okay? So you just want to hit on some misconceptions there of randomness and recency. We also want to talk again about sample size, okay? So sample size and the law of large numbers. Okay, so again, the sample size, whenever you're doing data, you want to make sure you have a large sample size, which will get us to the law of large numbers, that the larger the sample size is, the more probable that it's going to represent what your predicted probable outcome is going to be. So again, with the tossing coins, if you toss them 10 times, even though the probability is 1/2 or 50% that you would get a heads or a tail, you can still, with a smaller sample size, you can get 10 heads in a row, okay? Or 10, them all being heads. But if you flip them 100 times, that's a larger number, and you're going to see that those events will adhere to what the predicted probable outcome is going to be, the larger your sample size is, okay? So this lab today was to introduce you into probabilities and how we apply those in a daily example, like if you were buying a lottery ticket or playing blackjack or playing roulette. Roulette's kind of easy because, again, when you look at those outcomes, if you were betting red or black, 50-50 whether it's going to hit red or black or even or odd. But it goes up to 36, I think, on the roulette, so 36. And so if you were to bet on 2, then that's a 1 out of 36, your probable outcome there that it would hit, because you have 36 opportunities, and then you're choosing just one of those. So I'm applying it there. But if we were talking about blackjack, which is a little different, because you do the probable outcome out of the cards for your first card, and if there's 52 cards in a deck, and you get your first card, and then you're trying to count cards to see, well, what should I bet to see if I can get 21? Well, then you have to take into account how many players are there, how many cards have already been dealt, what's been dealt that you can see, and then adjust your probability from what's left. And so that's some real-world examples of how probability is in our daily life. And then we're going to apply this in lecture and next week lab, we're going to apply this to how this we see this in biological systems. And so, how can you think of what can you think of as how we can apply probability into a biological topic? And hopefully they'll say, oh, genetics. Okay, so we can look at making predictions by doing crosses of organisms. Okay. All right. So again, this is going to be a big thing in lecture with Dr. Elster. He's going to give you lots of examples. So if you're having trouble with probability, make sure you seek assistance, because I can guarantee that there will be probability questions on the next exam.